In this video, we'll be looking at how to solve exponential and logarithmic equations. There are two possible ways to solve an exponential equation. Both of them involve you isolating the exponential term first. So if there's anything being multiplied or added to the exponential term, then move that to the other side of the equation first. But the first strategy I'm going to show here is if you can rewrite both sides of the equation using a common base. For example, if you have something like 3 to a power on the left-hand side, and you can rewrite the right-hand side as 3 to a power as well, then try to do that first because it's a lot easier to just set the exponents equal from there and then finish solving the simpler equation. The second strategy is for when you can't write both sides using a common base, in which case you're going to still isolate the exponential term, but you're going to be taking log of both sides of the equation and using some of the logarithm properties to move the exponent out front and then opposite operations to solve from there. This second technique generally requires a calculator for you to finish. For the first example, I see an exponential term, but there's something being multiplied by it. So our first step is going to be to divide both sides by 2 and change this into 5 to the x over 4 power equals 125. Now this is going to be an example of the first strategy where I can write both sides of the equation using a common base. The way to recognize that is by saying since the left-hand side has 5 to a power, you want to see if there's a power of 5 that would equal this number, and in this case, that's 5 to the third power. This will not always be possible if you either can't figure out the number or don't think it exists, especially if it's a decimal or something, then you would rely on the second strategy where you're going to need a calculator to solve it instead. So since I was able to rewrite 125 as 5 to the third power, now I can have the bases cancel and just solve this equation instead. When does x over 4 equal 3? Well, if you multiply both sides by 4, then the answer is 12. So now let's look at an example of an exponential equation where we can't write both sides using the same base. On this one, I still have something that needs to be moved to the opposite side of the equation. This time my exponential term has a -1 attached to it. So I'm going to start this off by adding 1 to both sides of the equation. And especially when you're dealing with decimals, you're probably not going to be able to say, oh, I know 6.1 is 1.06 to the 5th power or something. Many times it is not that easy to identify the number. So in these cases, we take log of both sides of the equation. So just write log in front of both sides. And then the reason for doing this is because we have a logarithm property that allows us to bring the exponent out in front of the equation. So now I can say x times log of 1.06. And I didn't do anything on this side, so I'll leave it as 6.1. But now that I have x times this number, this is just an ugly decimal that you can type into your calculator. So whenever you have x times a number, you divide both sides by that number. So my answer is going to be log of 6.1 divided by log of 1.06. And these are not numbers I expect you to know offhand. This is something that you would just type into your calculator to get the final answer. Please practice inputting this yourself as well, because if you use the parentheses incorrectly, you may get the wrong answer. In this case, you should have gotten the number 31 point, and I'm going to round this to 3 decimal places, so 0, 3, 4. Now the last part of these directions said to substitute your answer back into the original equation. So what they're asking you to do is when you get an answer, you can check it by typing in 1.06 raised, and then type in the answer you got for x in this case, so to the 31.034 power. And then if you subtract 1 from that, I got approximately 5.100173996, and that's very close to this number. I did round off this answer, so that's why this answer is off by just a little bit for checking my work there. If we checked the first answer, it might be easier to reduce the fraction first, but you would be doing 2 times, and then 5 to the third power, because 12 over 4 reduces to 3. So if you do 5 to the third power, that's 125, times 2 is 250. So this one was exactly correct. There wasn't a rounding done. That's why it came out perfectly. Next, we'll look at how to solve some logarithmic equations. Now, the difference between exponential and logarithmic equations is that log equations already have a log in them somewhere. Exponential equations should not have a log anywhere, but you might use a log to solve them. So for these, if you see a log in the equation, you first need to isolate it, just like we did with the exponential terms. So you shouldn't have anything being multiplied or added to that log term. Then you're going to change it to exponential form by following the base of the log to the base of the exponent, following kind of like that matching system of saying, how do you rewrite a logarithmic equation into exponential form? And then you should be able to solve that equation from there by doing opposite operations. So a good way to summarize all of the solving techniques is if it's a log equation, change it to exponential form to solve it. If it's an exponential equation, take log of both sides to solve it. So you're always doing the opposite or the inverse operation. For our first example, we have a logarithmic equation, and there's nothing being multiplied or added to it, so we can go straight on to the second step where we change it to exponential form. Now this log doesn't have a base written, so remember that means that this is the common log, which has a base of 10. So the base of the log, the number on the other side is your exponent, and then whatever you're taking log of, that goes on the other side of the equation by itself. This one doesn't actually have anything else I need to do to finish solving. It already has x by itself, but I am going to evaluate that 10 to the fourth power is the same as 10,000. For the second example, I do see some numbers being added and multiplied by my logarithmic equation. So first we'll take care of the subtracting. It's kind of like the order of operations, but backwards for solving order. So if I subtract 5 from both sides of the equation, I end up with this. Next, I want to get rid of the number being multiplied by my logarithm, so I'm going to divide everything by 3. So that cancels the 3 on the left-hand side. And on the right-hand side, it leaves me with the fraction 4/3. So now we have isolated the logarithmic expression. This is the natural log, so the base e log. So once you get this isolated, now you can change it to exponential form, just like we did with the other one. So the base of my log is e. The number on the other side is our exponent, so this will be the 4/3 power. And we were taking log of x minus 2. So to finish solving this equation, you would just add 2 to both sides of the equation. And e to the 4/3, your calculator should have an e to a power key on it because e is a set number just like pi. So if you type in e to the 4/3 power, and then outside of the exponent, add 2 to that value, and you should have gotten approximately 5.794. Now again, we can check both of our answers by plugging these numbers in for x. So you can take 3 times natural log and then type in the 5.794 number minus 2 plus 5, and you should have gotten something very close to 9. Again, it's only going to be very close because I did round this off to 3 decimals. This one probably worked out exactly correct because we have log base 10, and your calculator does have a log base 10 key on it. So you should be able to type in log of 10,000, and it will give you exactly the answer of 4. That's how we know that we solved these correctly. So that's it for solving exponential and logarithmic equations. Just remember to always use the opposite technique. If it has logs in it, change it to exponential form. If it doesn't have logs in it, if it's in exponential form, then take log of both sides to get that answer. And that's all for the notes. Thank you.